Welcome to lesson 5.1.3, and in this lesson we will be looking at the factor theorem. Use the remainder theorem to determine the remainder when x squared minus 4x minus 21 is divided by each binomial and identify if the binomial is a factor.
So remember that when you're doing a question like this, if we're going to identify whether or not a binomial is a factor, really what we're looking for here is the remainder to be equal to 0. So when we divide by x minus 3, what we're going to do is we're going to take that polynomial and we're going to evaluate it at the value that makes the divisor equal to 0. So in this case it's going to be evaluating at 3. And when we do that, okay, we get 3 squared minus 4 times 3 minus 21. Okay, so what have we got? 9 minus 12 minus 21. 9 minus 12 is negative 3, minus 21, negative 24. Okay, and with negative 24 as the final value that we get here, we can conclude that this is not a factor, okay? That x minus 3 is not going to be a factor of this polynomial. Now, let's take a quick look at this next one here, x minus 7. Let's think, what value would make this binomial equal to 0? And the answer is 7. So we're going to evaluate the polynomial at 7. And so we get 7 squared minus 4 times 7 minus 21. This is going to equal minus 49 minus 28 minus 21. And actually, when you put those together, you do get 0. So what that means here in this case here is that x minus 7 is in fact a factor of polynomials. So we can conclude, therefore, x minus 7 is a factor. So that's the whole point. Okay, so the factor theorem is really just a very, very minor adjustment to the remainder theorem. If the remainder is 0, then the binomial we're looking at is a factor.
Which of the following binomials are factors of the polynomial p of x is equal to x to the fourth plus x cubed minus 7x squared minus x plus 6?
All right, as with the previous question, we're really going to figure out what values are going to make each one of these binomials equal to 0, and we're going to evaluate the polynomial at those numbers. But what we're going to do here in this case, we're going to make this a little bit quicker here. We're going to take that polynomial that we're being asked about, that x to the fourth plus x cubed minus 7x squared minus x plus 6. I'm going to plug that in here. So we're going to press y equals, okay, and we're going to enter in here x to the 4 plus x cubed minus 7x squared minus x plus 6. Just going to make sure that that's actually what it says there, and yeah, that's correct. Okay, so now that's in for y equals. Now I'm going to do this, we're going to evaluate these really quickly here. We're going to use the calculator to evaluate these things here. So remember, what I'm going to do here, if I'm dividing by x minus 1, if I want to see whether it's a factor or not, I would evaluate the binomial at whatever value makes this divisor equal to 0. In this case, it's going to be positive 1. Now I can do that on the calculator now by simply calling up that function. And I do that by pressing vars, okay, because everything is stored in a variable, and specifically the function that I'm looking for is stored in that y variable as a function, and there it is. It's function y1. That's the one I plugged in here. So I'm going to essentially make it look exactly like the way I've got it written right there. P at 1 is equal to, well, y at 1 is equal. Let's see what y at 1 is equal to. 0. So p of 1 is equal to 0, so therefore x minus 1 is a factor. Okay? Now let's go down here and we're going to check out x plus 2. Now let's think, what number would I have to evaluate the polynomial at to check to see if x plus 2 is a factor? Well, I would have to evaluate it at negative 2. So now I'm going to go up. Okay? I'm going to grab that function again, and this time I'm going to go back and edit it. I'm going to put a 2 in there. So I'm going to put a negative 2, my mistake. Negative 2. And when I plug negative 2 in, I get negative 12. Okay? So what does that mean? Well, because that's not 0, very simply, therefore x plus 2 is not a factor. Okay? Now, the next one. X plus 3. Well, what value of x would make this equivalent to 0? Well, negative 3. So let's plug that in. So again, I'm going to go back up real quick, press enter, come over here and change that negative 2 to a negative 3. This time I get 0. And so I know, therefore, that x plus 3 is a factor. And then finally, x minus 6. And it should be clear now that I would evaluate this at positive 6. So I will come up, grab that function right there, enter in, put a 6, and I get 1,260. So that's a huge value here. So that means therefore we know that x minus 6 is not a factor. Okay? So yeah, so I just wanted you to be able to see that there are two ways you can do this and that you can use the calculator to quite quickly run through a series of these if you need to.